Today we're looking at lesson 2.2, which is solving one-step equations. There's 4 properties here that should have been written down in your key concepts section, but basically it's giving you steps to be able to solve an equation. We're going to work with each property, and I'll talk about what it means when we get to each problem. So, this one we are asked to solve. Whenever we're asked to solve an equation, we're always trying to get the variable by itself, and when we're trying to get the variable by itself, we're trying to cancel out what's on the side with the variable. So in this case, we need to cancel out a minus 25, and the addition property of equality basically says that if you need to add to both sides to solve, then you would be using the addition property of equality. So you would add the 25 because you want to cancel it on the right side, and then whatever you do to one side, you do to the other side. So I'm going to also add 25. Now my goal is to get g by itself, which I've done that, and now I just need to figure out what g is. So 113 plus 25 gives me 138. Here's another example of the addition property of equality. Because you have j minus 87 equals negative 3, so to get j by itself, we need to take the 87 from that side, and we do that by canceling it out. So we do the opposite, you'll see, and we do whatever we do to one side, we do to the other. So j would be 87 plus negative 3, or 84. These are using the subtraction property of equality. So in order to solve, we would need to subtract 27. And we do that because 27 is positive. So to be able to cancel it on one side, and when I mean cancel, I mean make it 0 on one side, I need to do the opposite. So that's why I subtract. So k would be 30 minus 27, which is 3. Again, we're using the subtraction property of equality. I'm starting on the side with the variable, and I'm subtracting the 16 to make this side 0 and to have p by itself. So p would be by itself, and I'm doing negative 12 minus 16, which gives me negative 28. These are using this is actually a special way of solving. You would actually need to cancel out the fraction, and whenever you have a fraction, you're actually multiplying by its reciprocal to cancel it out. So think about when we were doing all of the different properties, the multiplicative inverse property, where you multiply by the reciprocal of the number, gives you 1 as the answer. That's our goal when we're trying to cancel out the fractions when they're with the variable, is to get it to be 1. So that means we need to multiply this one by 5/3, and that will make this now 1k, and that's our goal. And we're going to do that to both sides, times 5/3. So I have 6 times 5 is 30. 30 divided by 3 is 10. So 1k would equal 10, and that is my final answer. Now we need to go to this next one, which is 2/3 b equals negative 1/4. We need to cancel out 2/3, so we need to multiply by the reciprocal. That gives us 1b, and we do that on both sides. Multiply by 3/2, and that gives me negative 3/8. And that would be my answer. Because whenever I have a 1 next to the variable, that is the most simplified that I can have it. Now we have a word problem. We're going to solve the word problem by using an equation. So it says Allison is making a stained glass window. Her pattern requires that 1/5 of the glass should be blue. She has 288 square inches of blue glass. So if she intends to use all of her blue glass, how much glass will she need for the entire project? So what we need to do here is make an equation. So it says 1/5 of her glass should be blue. So we would say 1/5 of her glass. We could use B for blue. So 1/5 times B has to be for the blue glass. And it says she already has 288 square inches of blue glass. So we're going to put it equal to 288. Oh. So in order to solve this for B, to figure out how much you need for the entire glass, we're going to multiply by its reciprocal, which is 5/1. And we're going to do that on both sides. So B would equal to 1,440, which B actually was probably not the best one to use because we're doing for the entire project, so maybe E would have been good, or P. But any variable is fine as long as you set it up correctly. And that concludes Lesson 2-2.